One thing you should always be doing is optimizing your workflow, and part of that is automation. The simple way to do that is to learn some scripting skills and apply them. If you find yourself doing a similar task constantly, spend the time to make a quick script, and that will pay dividends down the road. The more of these little tasks that you can automate, the faster you will get. In Maya, that means learning a little bit of MillScript and maybe Python, but it's pretty easy to get started. Let me show you. Let's open up the script editor. But what we're looking for is under History and Echo All Commands. Once you toggle this on, you'll see in the log every command that you do in the window. Now it looks like a lot, but the thing is, you can isolate specific lines and use them in scripts. This is an easy way to learn commands if you don't know the context of them. Then you can go and search for specifics online and find the documentation. Let's grab this quad command. We can get rid of this because these are specific faces. The rest of these are shorthand for options on that tool, which you can just search for and find the documentation explaining what they mean. The documentation will spell out the long command and then the shorthand, and then give you the explanation, and then even some examples at the bottom. Use this to build your own simple tools. You can run a line by highlighting it and hitting the number pad enter button. Once you're happy with your script, you can highlight it and middle mouse drag it to your toolbar. Then you can customize it by opening Shelf Editor, locating your shelf in the specific tool, giving it a name, a tooltip, and loading an icon, and saving. Obviously, a command that's just one line is the same efficiency as adding a button to your toolbar, but the real power is when you start stringing these together. Here's a simple script that helps me cap holes in my mesh by filling the hole, triangulating it, and then quadding it. Like sometimes you have two pieces of complex geometry that need to be bridged between. This is simpler, and it can even account for uneven number of edges on each side. Obviously, this solution doesn't work for every scenario, but it works for specific ones. That's what scripts like these are good for. So I'm going to share with you all of my most useful scripts to help inspire you to make your own. This one hardens edges based on your border UVs. This script selects all hard edges. I often find myself editing edges to smooth them out and using a curve as a guide. This script smooths out curves. If you happen to need it even smoother, you can edit the value here. While I'm modeling, I don't worry about n-gons if they're not affecting the mesh, and neither should you if you know what you're doing, but at the end I clean them up using this script, which just selects any n-gons and triangulates them. This script toggles transparency for the default material, which is really helpful if you're working with some objects that you want to be transparent or against a reference plane. This one selects every other edge along a loop, and this one selects every other edge along a ring. There's a myriad of uses, but it's specifically helpful for reducing. These scripts are the basis of how I start my UV unwraps. I begin by defining all of my UV seams by hardening edges. Everywhere there's a hard edge will become a UV seam. A quirk of this is my cylinder objects always have a hard edge. Having a hard edge where your UV seams are basically free in vertex count. And the baker doesn't really care if this is a hard edge or smooth when it comes to baking. This doesn't work for every application, but for what I do, it works great. Keep in mind that interior cylindrical shapes will also need a hard edge seam. I select my object and run the first script. This auto unwraps selects all hard edges and then cuts along those hard edges. Then I invert my selection by holding shift and dragging over the whole object and run the second script. This script sews all edges that are not hard, unfolds, aligns UV islands to the grid, and scales them to a textile density, which is defined here. This doesn't give flawless results, as I will need to correct some alignments and straighten some UVs, but it's a good start. That's all my custom scripts that I use most often, but that shouldn't be the end for you. Use this more as an inspiration to start making your own and making your workflow more efficient.